Hello everyone. In this lecture we will be seeing another example of converting an NFA to a DFA. Alright, so let's get started. Okay, so here we have a question. Find the equivalent DFA for the NFA given by M equal to ABC, AB del AC, where del is given by this. So what is the meaning of this? This is actually the formal definition or the formal way of representing an NFA. So in the previous lectures I have already taught you how an NFA is formally defined. So I taught you that NFA is defined using 5 tuples: 1, 2, 3, 4, 5. Where what does this tuples mean? This tuples means that this first one, A, B, C are the states. We have 3 states A, B, C, and then the second tuple is the inputs, which are A and B, and then we have a transition function del, and then this A shows that this is the starting state or the initial state, and this C is the final state or the accepting state. And here del, the transition function del, is defined by this table over here. We have 3 states A, B, C. A on getting input A goes to both A and B. A on getting input B, it goes to C. B on getting A, it goes to A, and B on getting input B, it goes to B. And C on getting input A, it goes nowhere. That means it has no move, it goes to 5. And C on getting input B goes to states A and B. And here A is the initial state, that's why I have given this arrow, and C is the final state, that is why I have given this circle around this. So before we proceed, let us just draw the state diagram for this NFA. Okay, so here I have drawn the state transition diagram for this NFA. We have 3 states A, B, C. A on getting small a goes to A itself, and also it goes to B, and A on getting input small b goes to state C, and state B on getting input small a, it goes to state A, and on getting small b it stays in B itself, and C on getting input A does not go anywhere, and C on getting input small b it goes to state A as well as state B. Now we will convert this to the equivalent DFA, and we will be using the subset construction method that we have discussed in the previous lecture. So I'll use this table to convert this transition table to the equivalent transition table for DFA. So what will be the elements in my table? I'll have my inputs A and B, and what will be the states I have? I'll start with the starting state or initial state, which is state A. And then let's see, A on getting input A, where does it go? A on getting input A, it goes to 2 states A and B, but in DFA a state on getting a particular input can go only to 1 state, so we cannot send it to 2 states. So I will combine A and B and make a new state which I will call AB. AB is a single state, alright? And then A on getting input small b, it goes to state C. And then what will be the next state that I have to discuss? Here, we have to first check what are the states that is reachable. The only states that are reachable are A, B, and C. So I can start with either A, B, or C. Let me start with A, B. I'll discuss state A, B. And how do we do this? In order to know where does A, B go on getting input A and B, we have to look at this table and look at both states A and B, because we are doing A, B here. So look at states A and B and perform the union operations of A and B to get the result here. So AB on getting input A, where does it go? For that, look at this. A and B, perform the union operation of A and B on getting input small a. So union operation of A and B will be A, B, and A. So A is common. The next thing is B. So it will be A, B. So this will be A, B. And on getting input B, where will it go? Perform the union of this, union of B and C. So it will be BC, capital BC. Okay. Now let's see what are the states that are reachable. AB and BC. So AB is already discussed. The next one is BC. Let me write for BC. BC. So how do we do for BC? Look at this table and perform the union operation of B and C. So on getting input A, union of B and C is A and phi. That means just A, right? Just A. And then on getting input B, what happens? Perform the union operation of B and C on getting input small b. Union operation of B and AB will be AB itself. AB. Okay. Now what are the states reachable from here? A and AB. A is already discussed, AB is also already discussed. And what is remaining that we have not discussed? We have not discussed state C. So let us write for state C. So in state C, when state C gets input A, it goes nowhere. But in a DFA, we cannot leave a state like that. We have to mention where a state will go when it gets a particular input. We have to send it somewhere. So in this NFA, it goes to phi. So phi in DFA is equivalent to a dead state. So I will make a new state here which I will call D, where D will be my dead state. Okay, and C on getting input B, where does it go? It goes to both A and B. So I cannot send it to both A and B. I have to combine AB and make a new state called AB. So we have already made that new state AB here. So I'll send it to AB. Okay, and now is it complete? It is not complete. Why? Because I have mentioned about a new state called D here, which is the dead state, and I have to also write what happens to the dead state in order to make the DFA complete. So let me mention for D, state D. D on getting input A and B, where does it go? We know that dead state, in a dead state, whenever any input comes, it has to stay in the dead state and it just gets trapped in the dead state. So whatever comes to the dead state has to stay in the dead state. So in dead state D, whether we get input A or B, it stays in the dead state itself. D. Now my table is complete. But here we have mentioned what is the initial state, but we did not mention what is the final state. So what would be my final states among these states? So we see that in the NFA, C was the final state. So in DFA, what will be the final state? In NFA, since C was the final state, I have to make all the states that contains C in this DFA as final states. So I see that here in BC there is C and here there is C. So both of these states should be my final states. So I'll put a circle around them, around both of them, indicating that both these are the final states. Okay, now we have made the transition table. Now let us try to draw the transition diagram for this DFA. So let me start with my starting state A. A is my starting state, and A on getting input small a, it goes to state AB. Here I'll mention state AB here. Alright, A will go to this AB on getting input small a, and A on getting input small b, it goes to state C. So I'll make another state here called state C, and we have to note that state C is a final state, so I have to put two circles around state C. Okay, A on getting what input does it go to state C? On getting input small b. A on getting input small b, it goes to state C. Okay, now coming to state AB. AB on getting input small a, it stays in AB itself. Stays in AB itself on getting input small a. And AB on getting input small b, it goes to state BC. So I have to make a new state BC here. BC, and we have to note that BC is also a final state, so we have to put two circles around it. So AB goes to BC on getting in, AB goes to BC on getting input small b. Getting input small b, it goes to BC. Okay, now we have finished for AB. Now coming to BC. BC on getting input small a, it goes to A. BC on getting input small a should go to A. It is on getting input small a. And BC on getting input small b goes to AB. BC on getting input small b, it has to go to AB. That is on getting input small b. Okay, and we have completed BC. Now coming to state C. C on getting input A goes to D, which is a dead state. So I'll make a dead state over here, which I'll call D. So C on getting input small a goes to D, and C on getting input small b goes to AB. On getting input small b, it goes to AB, and that state, that is D, on getting input A and B, it stays in D itself. So whatever it gets, whether it is A or B, it stays in B itself. So here we have completed the DFA for the NFA that was given. Using our subset construction method, we have constructed this DFA. So I hope this was clear to you. And now if it was clear to you, I would like to give you one assignment, one task. And the assignment will be, try to find out what does this NFA and its equivalent DFA accept. So here in this lecture we have discussed about this NFA and we have designed its equivalent DFA. Now your task will be to find out what this NFA and this DFA accepts. We did not mention what kind of strings or what is this DFA and NFA doing. What is its task? What is it actually accepting? What kind of strings is it actually accepting? So try to find out what this example that we have discussed accepts and try to leave your answer in the comment section below. So thank you for watching and see you in the next one.